The incident channel is quiet because nobody noticed the agent was wrong. The code compiled, the ticket moved, and the real failure was behavioral and operational. The agent kept taking plausible steps after the goal had already drifted. This is lesson 26 in Claude Code, Production AI Agents. We are building a failure mode map for agents because reliability starts by naming how they fail. Lesson 25 gave us traces and timelines. Now we use that evidence to classify failures, detect them earlier, contain blast radius, and decide who owns recovery. The core idea is this: AI agents fail through behavior, context, tools, permissions, and operating assumptions, not only through exceptions. That means the answer is only one part of the system. The path, controls, ownership, and recovery plan matter just as much. The visible artifact is the agent failure mode map. It has 5 parts: failure class, detection, signal, containment, rollback, owner. Those parts turn an abstract concern into a concrete review conversation. This part of the visual map matters because it shows the actual moving pieces: failure taxonomy, SLO, error budget, circuit breaker, rollback plan. If one of those pieces is invisible, the team will struggle to operate the workflow under pressure. Use this checklist before treating the workflow as ready: failure class, detection signal, containment, rollback, owner. These are not decorative boxes. They are the operating questions that decide whether the agent can be trusted outside a demo. In practice, this example has 4 parts: silent wrong action, looping behavior, tool misuse, context corruption, unowned incident. The point is to make the agent's work inspectable rather than asking everyone to trust a polished final answer. Score the design against this rubric: failure class, detection signal, containment, rollback, owner. A weak score does not mean the idea is useless. It means the workflow needs stronger boundaries before it becomes production work. Day 2 is the real test for failure modes and reliability engineering. A model version, tool version, policy update, or team workflow change enters the system. The team should be able to compare the new run with the previous run, inspect the evidence, and decide whether the difference is improvement, regression, or noise. Without that comparison path, the agent may change faster than the organization can understand. Use this implementation checklist before expanding scope: failure taxonomy, SLO, error budget, circuit breaker, rollback plan. Each item should produce a concrete artifact, not only a meeting note. If the artifact cannot be inspected later, it will not help during review, audit, or incident response. Block release when these risks appear: silent wrong action, looping behavior, tool misuse, context corruption, unowned incident. A blocked release is useful information. It tells the team where the system needs stronger evidence, better calibration, narrower scope, or clearer ownership before it reaches production users. Before a leader approves wider rollout, answer 3 questions in plain language. What decision will this evidence support? Who owns the signal when it disagrees with human judgment? What happens if the signal is wrong during a real incident? These questions connect failure modes and reliability engineering to accountability instead of turning it into another dashboard or checklist that nobody trusts when pressure rises. A useful mental model is aircraft incident board. It reminds us that production work is not about trusting a perfect machine. It is about designing a system that can be inspected, corrected, and improved under pressure. Our worked example is an incident response runbook for a production coding agent. In that workflow, the important pieces are failure taxonomy, SLO, error budget, circuit breaker. The agent can still accelerate the work, but the operating model must make important behavior visible. The build sequence is simple: Define what can go wrong, define the signal, decide the release gate, assign ownership, store the evidence, review failures, improve the workflow, repeat. That loop is slower than a one-off prompt, but it is how agent systems become dependable. Use the readiness rubric: failure class, detection signal, containment, rollback, owner. If a team cannot point to each part, the release is relying on hope. Hope is not an operating model. The common mistake is treating agent failures like ordinary application errors. It feels efficient because it avoids upfront design. It becomes expensive when the agent drifts, fails, or creates a decision nobody can explain. Let us recap Lesson 26. For failure modes and reliability engineering, define the risk, capture the evidence, connect the result to a release decision, and keep ownership clear. Quality should be visible before trust is requested. The lesson learned is this: AI agents fail through behavior, context, tools, permissions, and operating assumptions, not only through exceptions. A production agent earns trust when quality, risk, and history are visible. Subscribe for Claude Code Production AI Agents. The companion book is linked in the description. In Lesson 27, we turn reliability into money and look at the hidden costs of production agents.